Day 2. So we did an example yesterday with the gears, and really it's the same thing. S1 equals S2. Okay. So again, let's look at the small gear has a radius of 2.5 and a central angle of 225. So it's rotating 225 degrees. Maybe from here all the way around, starts here, ends here. Okay, so I'm going to do this. I'm going to say R 2.5 times 225 times pi over 180. That is radius times theta. Okay. Now, we can go ahead and multiply that out if you'd like. 225 times 3.14 divided by 180 times 2.5. Let's go ahead and see what that equals. So 225 times 3.14 times the radius, which is 2.5 divided by 180. Since we have a 180 in the denominator, that gives us the left side, which equals about 9.68. Okay? So that is the left side of our equation. So that would actually be the arc length that the small circle makes. Well, the big circle has to make the same thing, but it's going to be r times theta. Now here, the question through how many degrees does the larger rotate? So we don't know theta. But again, the formula works in radians. So this is our unknown in radians. Our radius is 4.8. Okay? So if you take 9.6 divided by 4.8, you get your angle, which is 2. 2 what? 2 radians. So how are we going to convert from radians into degrees? Well, we're going to take our angle in radians and multiply it by 180 divided by pi. So if you multiply that out, you should get about 117, 116, I think. You can work it out. I don't really care about labeling so much, but probably 116 degrees. So that should make sense because the small angle, the small gear is going to rotate a bigger amount than the big one is going to rotate. It's going to only rotate about 116 degrees. This arc length has got to equal this arc length. Okay, when they spin. Okay, so one other thing here. Let's take a look at one other application here, and that would be area of a sector. So this is a sector, a piece of pie, piece of a circle. Okay, it's a fraction of a circle. So the old school way of doing it is to take your central angle, theta, and I'm going to think about it in degrees right now. Theta in degrees over 360 times pi r squared. This is the area of a circle. So it's a fraction of the area of the circle. If it was 90 degrees, it would be 1/4 of the area of the circle. Okay. Now, let's do this. Let's come up with a formula for radians. So we've got theta in terms of degrees divided by 360 times pi r squared. So I'm just going to move that over here, and because what I'm going to do is I'm going to put in a conversion factor. I'm going to take this and I'm going to convert it into radians. So I'm going to multiply by 180 over pi. So this is going to be 2. This factor cancels out with this factor. So your formula in terms of radians should be theta divided by 2, or 1/2 theta times r squared. That's a formula for the area of a sector, the area of this piece right here. So 1/2 theta times r squared. That's your formula. So let's apply that on the next page. So I'm going to write the formula down. Area of the sector is 1/2 times theta r squared. That theta is your angle in radians. So let's find the area of the circle. So the unknown is area. So 1/2 of 3 pi over 4. Well, let's just kind of think about this. Pi over 4 is 45. 3 times 45 is 135 degrees. You're not going to use that in the formula, but it's 135 degrees times r squared. So it'd be 1/2 of 3 pi over 4 times 64. Okay, divide this into 64, that's 16. Divide this into 16, and that's 8. You have 1 times 3 times pi times 8, so that's 24 pi. That is the area of this sector. Let's say we're talking about centimeters, so it's 24 pi centimeters. So find the area. Here, find the angle. So that's theta. So I'm going to write the formula down. A equals 1/2 theta times r squared. Let's plug in 24 pi right here for the area. So we do not know the angle. We do not know theta. We do know r, so that's 6 squared. So this is our unknown here. We're solving for theta. So the right side of the equation is 36 times 1/2, that's 18. So we have 24 pi equal to 18 theta. So let's solve for theta by dividing by 18. And this is our angle in radians right here, 24 pi over 18. So that's a perfectly acceptable answer. Probably would want to simplify it. So I see a common factor of 6 here. So I'm going to divide the top by 6 and I get 4 pi, and divide the bottom by 6 and I get 3. So that's your angle in radians. Well, that's 60 degrees. 4 60s is 240. It's a 240 degree angle, however they want you to leave it. Okay, so again, if you want to convert into radians, it's 4 pi over 3 times 180, 240. Okay. Okay, so we got one left. We're going to solve for the radius now. So the formula is area equals 1/2 theta r squared. So let's plug in our radius, or our area, of 60 pi. And let's solve for r. This is our angle, 5 pi over 6. So let's work on that arithmetic here. Okay? I'm going to just kind of flip it over to another page here. I'll rewrite it. So again, we have 60 pi equal to 1/2 r squared 5 pi over 6. So I'm going to just solve for r squared. So I'm going to try to simplify this. So if you multiply this numerator is 5 pi r squared over 12. So let's solve for r squared. Let's get rid of this. I'm going to multiply by the reciprocal. So I'm going to multiply by 12 over 5 pi. 12 over 5 pi. So we have r squared equal to, that would be 144. So your radius is 12. Hello. Hey, what?